All right, good morning, everybody. Make sure you go slow and careful. Do not fast forward. Do not collect an extra $200 for pass and go. This is the Test 5 review, so let's take a look at what's coming at us. So, one we just got done talking about, when you list factors of a number, you have to do both steps every time. You start off thinking, what times what? So I always recommend starting off with the two easy ones, right? 1 times 18. And you also got to remember your divisibility rules. Is it even? If it is, 2 is always a factor, whether it shows up on your multiplication chart or not. In this case, we have 2 times 9. Is there anything else equaling it? In this case, yes, we would have 3 times 6. So I'll cut to the chase. There is absolutely no other numbers that equal 18 as factors. But once you have them there, now we have to put them in order from least to greatest every time. You don't start with this step. This is the last step. So I have 1, 2, 3, 6, 9, 18, right? Get them listed in pairs first. Don't go right to this step because nobody is that good in math, including myself. All right, 1 down, just a few more to go. Let's take a look coming at us from lesson 21. I had a lot of people over this week. They're still a little fuzzy about how lesson 21 problems are set up. Those are your multiplying problems. Number of groups times the number in each group gives you the total. Remember when we had those little pictures of boxes and baseballs? The boxes would be like the number of groups. The baseballs is the number in each group. But some people are just guessing. Is it add? Is it subtract? Go back if you can't remember to lesson 21. So you also got to read the problem really carefully and think. 25 desks are lined up in 5 equal rows. How many desks are in each row? Well, they gave us 25 desks. That sounds like the total number of desks in the whole room, right? Are lined up in 5 equal rows. The rows is your number of groups. And pick a variable. Maybe I'm going to use D for desks, right? I want to isolate the variable, so I want to get times 5 over to the other side, kick them on over, and then I want to go and just do the opposite sign. So I'm going to start off with D, then I'm going to have equals, then I have 25. Only this time, instead of 25 times 5, I do the opposite sign, right? 25 divided by 5. I have some terms to combine. I'm getting some people at this step get really wonky and D starts ending up over here. We read equations left to right. First thing up I run across is D. The next thing I run across is my equal sign, but I underline to combine my 25 divided by 5, so D is equal to 5, or 5 desks. Let's try another one of these. Also, number of groups times the number in each group gives us the total. There's 4 rows of desks with 4 desks in each row. How many total desks are in the room this time? And if you didn't catch it, here's your clue word right there, right? They want us to find the total. In this case, put your variable over here. 4 rows of 4. Rows is the number of groups. 4 desks in each row. That's the number in each group. One of those that's so simple it's hard. I have terms to combine right off, right? What's 4 times 4? Hey, that should be 16. Then I have my equal sign. And then I have my D. 16 equals D. Check out this one. What is the sum of 219 and 421? Hopefully you need to know what a sum is. And I had some of the people not even getting this right the other day. You can always look in the back of your book. This is a test. Take the extra 2 minutes. If you're not sure, that sum means the answer when you add. So then you would just have to add 219 and 421. I don't think I need to go and review that though right now, so I'm going to move on. Take a look here. Which problem below illustrates the associative property? And the word associative property, that's based on the root word associate. And when you say who people associate with, they're talking about who they're hanging out with, who they're close to. So the parentheses is all about the associative property, because in this case 3 and 4 are associating. But in this case over here, 2 and 3 is associating. So it is example C. If you're not sure, you can always turn to lesson 24 and look at the lesson. Check out this one coming at us from our friend Investigation 2, where the big thing to remember was if the numerator is 1, always divide by the denominator. So let's see what we got going on here. In the class, 1/4 of the 20 students play football, 1/2 of the students play baseball, and 1/2 of the students play soccer. So they want to know how many students play football. So let's find out where it's talking football. Here's football, right? But we got a period at the end. I had some people the other day, they're pointing at a word, but you know what? The period means, back up on the sentence and go all the way to the front. Then start reading. In the class, 1/4 of the 20 students play football. 1/4 of 20. Divide by the denominator. So let's get it set up. I have 20 total students, and 1/4 of them play football. My denominator is 4. So think, 20 divided by 4. Man, we have this on our quiz almost every day. That should be 5 students, right? Let's try another one. Same problem, only now they want to know how many students play soccer. Well, let's take a look. 1/10 of the students play soccer. 1/10 of the 20 students still. We're still talking about the same group of kids. Only this time it's 1/10 of those kids. Well, the numerator is still 1. Only I'm talking about 1/10 of them. So they want to know how many kids are playing soccer. 10 times what is 20? And hey, that answers 2. So a lot of times kids will stumble over this one. Remember, do the work in parentheses first. I guarantee if you do this problem just left to right, you're going to get a wrong answer. So I have 3 times 2. 3 times 2 is 6. Then let's go ahead and add on the 2, which is going to give you a final answer for 8. Because in this case, the associative property does not apply. If I put parentheses here, I'd come up with a totally different answer. So after lesson 26, this guy should be a piece of cake. But those people who are making division problems, mistakes, listen up, I'm talking to you. This is 60 divided by 9, right? So this is where the number one amount of mistakes I see. People are trying to start writing right above the 6. You got to be nice and neat. Think, if you had 9 people coming over and only 6 chairs, does everybody have a place to sit down? Can you divide 9 into 6? No way, at least not in 5th grade. But it can divide into 60. So this is where you're going to start writing your first quotient digit. Nice and neat, right above that 0. And you got to think, 9 times what gets me close to 60? If you don't know that, we're in trouble already. We better figure something out here pretty quick. 9 times 7, no, that's going to be too big. 9 times 6, it's going to be. Multiply it back, the number you just wrote, going back down for 54. Go and subtract those two numbers, right? 60 minus 54, and that's going to give us 6. Do you have any more numbers to bring down? No, you don't. So your remainder gets written over here. I'm seeing people who are still making mistakes on these. They're trying to write the remainder over here and it's messing them up. You got to use the numbers in the divisor to keep track of where you are at in the quotient. You cannot approach these problems too sloppy. It's going to mess you up. Okay, another straight up dividing problem. The easiest way about these, just think. 4 times what gives me 36? Hopefully you know there. 4 times 9. So 36 divided by 4 is 9. Here we have one where you gotta compare. Do not be thinking you want to go too fast. Work them out and you gotta do the problem in parentheses first. Because again, the associative property does not apply here, folks. 3 plus 4 is 7. Then do the last two problems. 2 times 7, hey, that's 14. Now let's go and take a look at the other side. 2 times 3, hey, that's 6. Now go ahead and do the third part of the problem. 6 plus 4, that's 10. These two problems are not equal. The associative property does not apply. 14 is greater than 10. So check out these guys. Which fraction is not equal to a half? And we have said to be equal to a half. I still got people writing the big number up on top. Look at all these fractions. Do you see anyone where the numerator is larger than the denominator? No, I don't see one like that either, right? In order for a fraction to be equal to a half, if you started with the numerator and timesed it by 2, it's going to equal the denominator. So does 4 times 2 equal 8? Yes, it does. Does 25 times 2 equal 50? Yes, it does. So that guy equals a half. Does 100 times 2 equal 200? Yes, it does. Does 12 times 2 equal 25? Hey, wait a minute. 12 times 2 is equal to 24. So 12 25ths obviously cannot equal a half. Check out this guy. Not too tough. The trickiest part about this problem is going to be setting them up one on top of another, right? But the other tricky part is if one of the numbers in the problem is written with a $sign and a decimal point, they all have to be written with a $sign and a decimal point. Go and write in your extra zeros. Don't go and stick $5 over there. That's just going to be awfully silly. If one of them has a decimal point, they all have to have a decimal point. It'll make your life a whole lot easier. And then let's just start subtracting. Can you go 0 minus 3? No, you can't. So he goes to his neighbor. His neighbor says, no, man, I'm broke. He goes to his neighbor and says, yeah, I got 5. I can loan you 1. And he goes and only pays the neighbor on the right. Now he has 10. Hey, I got 10 now. Score. I can pay you. So his 10 becomes 9, and he pays his neighbor. 10 minus 3 is 7. 9 minus 3 is 6. Bring your decimal point straight down into the answer. 4 minus 2, that's 2. That is officially the end. Make no mistake, you get no special prize for finishing first. And I probably need to clarify, don't just read your answers if you think that's the way to double check your test. You got to read the problem and then the answer. If you're just reading over your answers, that's going to do you no good. I really should not see anybody done with the test at least in the first 20 minutes if you're serious about this. All right, let's have a good time taking the test. Go slow, go careful, do your best. Good luck.